Hello everyone, in this video we'll be solving a easy problem number 9, palindrome number. The problem statement is given an integer x, return true if it is a palindrome or else return false. In example number 1, where x is equals to 121, as the number is a palindrome, the output is true. But in example number 2, where the number is negative 121, it is not a palindrome. If we reverse the number, it will be 121 and with a minus sign or a negative sign, which is not equal to the original input, hence the output is false. There are multiple approaches to solve the problem. The most simplest and the easier way is to convert the entire number into string, then reverse the string and then compare it with the original value. If the values are equal after reversing, it is a palindrome and we can return true. If we were to take this approach, our time complexity will be O of n, where n is the number of characters in the given number, and the space complexity will also be O of n, as we are creating this reversed order variable and then comparing it against the original string. Although this approach solves the problem, there is one another way which we can use where we don't need to convert the given input into the string format. We can use the number as is to check if it is a palindrome or not and accordingly return true or false. So let's switch to whiteboard and discuss that approach. One way to verify if a particular number is a palindrome or not is to divide the entire number by half, that is divide it based on the number of digits, and then compare the first half with the second half after reversing it. In a palindrome number, the first half of a number is always equal to the reversed version of the second half. If we apply this logic to the given input, the first half is 12 and the second half is 21. Now if we reverse the second half, it will become 12, which is equal to the first half. Hence the number is palindrome. Let's try a different number, that is 1, 2, 2, 3. Applying the same logic, first half is 12, second half is 23, the reversed version is 32, which is not equal to the first half, hence the output is false. This logic is straightforward when there are even number of digits. What if there are odd number of digits in the input? Let's cover that scenario too with this input 1, 2, 3, 2, 1. Now if we were to calculate the midpoint of this number, it is 3. Now to look at the first half, we could include 3 in the first half or we can exclude it. If we are including it, then it has to be included in the second half as well, or if we want to exclude it, we need to do the same on both. Let's say we exclude it. So the first half is 12, second half is 21. Reversing that will give me 12, which is equal to the first half, hence the number is palindrome. And if we were to include it in both the sides, the first half will be 123, the second half will be 321. Reversing that will give me 123 on the right hand side, which is equal to the first half, hence the number is still palindrome. I hope you are able to understand how we broke this problem down into smaller pieces and compare the first half with the second half to check if the number is palindrome without having to convert the integer into string format. With this solution, the time complexity is O of log n to the base 10, where n is the size or the number of digits in the number. This is because we are breaking down the number into halves and then processing them. Hence, the time complexity is not O of n and instead it's O of log n. And the space complexity is O of 1 as we are only using one additional variable to record the reversed version of the second half of the number. Let's walk through the solution in Java. Here's the solution in Java. In the main method, I've added a couple of validations to make sure that the input is in a valid range. The number cannot be negative or it should not end in 0. Will return false if either of the conditions are met. After that, I'm initializing a variable reverse half, setting the default value to 0 and then running a while loop to build the reverse version of the second half. Within the while loop, I'm using the mod and the multiplication operation to build the reversed version of the second half. At the same time, we are trimming the number of digits from the original input, that is x. The idea is to make sure that x contains the first half of the original input. After the for loop, if there are even number of digits in the original x input, I can simply compare x with the reversed half to see if they both are equal. If yes, then the number is a palindrome. But in case of an odd number of digits, We need to divide the reverse half by 10 because it will have one extra digit, and then compare it with x to check if it's palindrome. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 62% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.